Okay, this is the UT Quest forces and friction problem with pulling the sled with the penguin on it. And the idea is I want to find the maximum force that I can pull on the sled without pulling it out from underneath the penguin. Okay, the key to this problem is, first of all, we're going to want to use 9.8 instead of 9.81 for G. And we're going to use that, and we're going to find the force of friction that the sled applies to the feet of the penguin. That is the maximum amount of force that I can apply to the penguin. If I exceed that force, then the penguin's going to slip off. So that's going to be a critical force for me to calculate. That force is going to be equal and opposite to the force of friction of the penguin's feet applied to the sled. And that reaction pair is actually going to help us simplify the problem. So I'm going to look at it as a part, just the penguin, and then I'm going to look at it as a whole. Okay, I need to find out what this force is that's going to accelerate the penguin forward. And that, as we said before, is the static friction between the penguin's feet and the sled. So I'm going to need the force normal between the sled and the penguin. All right, so let's do our free body diagram of the penguin. I know his weight, and I know his force normal. It's going to be in equilibrium to his weight, so I can get that value. I'm given the mu static between the penguin and the sled, so I can easily calculate this force of static friction. Once I know that force of static friction, I can put that in Newton's second law. That force friction is the only thing accelerating the penguin forward. And I know that I can back calculate the mass of the penguin, and I get acceleration. Now I'm going to look at the entire system using this acceleration that I know. Okay, and I'm also going to use the fact that these friction forces between the penguin and the sled and the penguin by Newton's third law are equal and opposite. So those are internal forces that are going to cancel out. So I can look at this system as one solid mass that's holding itself together. Okay, let's start out easy. We always want to compute the weight. So we want to compute the weight in order so we can find the force normal. Again, in the vertical direction, we are in equilibrium. So the force normal is going to be the same value as the weight. Okay, this force applied is going to be opposed by the force of friction between the sled and the snow. That's a sliding actual motion, so we call that a dynamic friction force between the sled and the snow. We know our force normal, mu k is given. We have everything we need now to go into Newton's second law. We know all of these variables, or we have computed them, therefore we can solve for the applied force. Again, remember to use 9.8 instead of 9.81. That gave me a closer calculation. Should have been given in the problem, but it wasn't. All right, good luck with this.